try to solve another Leetcode problem 250 called Univalue Subtrees. So for this problem, we are giving the root of a boundary tree, and we're going to return the number of Univalue subtrees. So for example, this 5 here, and this 5 is a Univalue subtree because there's only one valid value, which is 5. So for example, this subtree is also a Univalue subtree because this is a root node and its children is also 5. So in total there are going to be 4 subtrees, so we're going to return 4. And for this one, because it is empty, so we're going to return 0. And for the last example, it's going to be 6, but I will not check that. Yeah. So we can use brute force to solve the problem directly. Let me just define a self.result. It's going to be 0, and finally I'm going to return self.result. Yeah. Let me define a main function of DFS. So this is a node. So I'm gonna write a pre-order traversal. So if node, I'm gonna use a check uni value. Check uni. If check this node is valid, yeah. So self dot result gonna plus equal to 1, and then I'm gonna run DFS node dot left and DFS node dot right. Yeah. So currently I set the self dot result gonna be 0, and then I'm gonna run it from the root. Yeah. So in this way, I'm gonna check one by one. So for example, I'm gonna check this 5. If it is valid, I'm going to plus 1. So it is not valid. This one not valid, but except that all others are valid. So yeah, I get the final result, which is going to be 4. Yeah. Now I need to write this check uni function. Basically, this is also a pre-order traversal function. We can write it later. And inside, I'm going to prepare an empty set. Now let's just define this check uni. And I gonna give a node, and I'm gonna give a empty set. Let me set it like s. Yeah. So let me just copy the code because it's gonna be exactly the same. Let me just copy the code from here. Yeah. Now for here, we just check each one of the node. For example, if it is here, we just check if it is a valid node. And as this is a set inside, so if node, so the set gonna add node dot value, and then we're gonna run left and right, and finally we just needed to return the self dot the set equal to 1 or not. If it is equal to 1, definitely it is a valid, so we're gonna plus a 1. Otherwise we will not do that. Yeah. Now let me just run it. Oh, it didn't work. Yeah, let me check the first example. Definitely it is wrong. Why there are 17 different cases? Yeah, because normally for this DFS here, I'm gonna update if this is valid, I'm gonna run. Yeah, I'm gonna update the self.result. Basically it's gonna be, yeah, it's gonna be 4 instead of 17. Let me check if I did something wrong with it. So let me check it from here. If length of the, yeah, I didn't put the set inside. Let me put the set inside. I think this is why it didn't work. Yeah. Yeah. Let me just correct my check uni function. Now I have 2 variables. Oh, this is not DFS, definitely. This is why it is wrong. Let me copy and paste the right function. Yeah, now as you can see, it works. Yeah. Yeah, maybe I'm tired. Just ignore a lot of things. Yeah. It works, but it didn't so fast because this is just like O(n) squared time complexity, but it is okay. Or we can stop it earlier. So for example, if length of the string, length of the set more than 1, so we can return a false immediately from here. Yeah. Now let me just run it and submit it to check if it works. Now as you can see, it works and it's pretty fast. Maybe, yeah, just prepare this kind of checking and then speed up to 100%. But anyway, this is okay. Yeah, anyway, this is a ON square time complexity. Thank you for watching. See you next time.